Hi guys, this is going to be the video that will help you fill out your amazing book of exponents. And before we begin, of course, we have to take care of some of our details in your interactive notebook or your handy dandy notebook. I think I'm just hilarious saying that. Go to page 22. Go ahead and pause the video right now and I'll zoom it up and you can make sure you fill this out right. Exponent, P-O-N-E-N-T. Of course, I spelled that wrong. Exponent word problem booklet, and it's more of 2.5, and then the absolute value. And really quick, I want to show you what page that will look like. So if it's page 22, your overall page is going to be roughly divided into fourths. You're going to have later an absolute booklet at the bottom and a fun little workshop game page that you'll need next to it. So in the top, you will have your Mrs. Smith's Amazing, which of course you'll have your name here, Book of Exponent Problems. And right here, I want to give you some basic notes that are going to help you out when we start our booklet. And that is exponent, IAL, growth question. I've seen a lot of that really works well with the 7th grade level topics. And they always seem to follow a pattern where you will start with a certain amount of value. Maybe a sapling is 6 inches high, or maybe you're being given a nickel for your birthday, and you're thinking, what? A nickel? Well, let's check out how exponential growth will grow that nickel very quickly. The next part is we're always multiplying that by the change. Here, I'm going to say it triples. You could say it doubles or it halves, right? Divide by 2, cut in half. So you're talking about whatever the changes multiply towards your starting point. And then this is going to be, this is your base with an exponent. The exponent is how many times we have that growth. Okay, so maybe it's going to triple a week every week for 5 weeks. So let's look at that. And if you haven't maximized your screen, I would do so now. So looking at this, starting with only a nickel, this is our starting point, but then our nickel will triple the first week. And then again the next for 2 weeks, 3 weeks, 4 weeks, 5 weeks. Now do you see how we have our starting point times 3 to the 1, 2, 3, 4, 5th power. So we would write that 0.05 times 3 to the 5th power. My mind, I see 9 times 9 times 3, and 9 times 9 is 81. And 81 times 3 is 243. Well, how much is that nickel when you multiply it times 243? 0.05 times 243. Wow. You end up with $12.15. Not bad for just 5 days when you only started with a nickel. All right, so you've got your notes here. Let's talk about your book. You should have cut apart the questions and glued them. So really quickly, I'm going to flip through so that you can make sure you have them in the right order. Or you can pause the video and apply them. First one is the bamboo plant. Then we talk about Miss Smith. Next will be the country club. Then something that Grandpa's going to do. And the last 2 questions is talking about volume. All right, so here we go. Question number 1. Again, if you haven't maximized your screen, do so now. My bamboo plant started at 4 inches. Well, that's handy. I know right where to start. Remember? It triples in size. Well, tripling in size means times 3. Every week, how tall is it in the fourth week? Well, to the fourth power, because I start with 4 inches, and then I triple it, and it triples again, again, and again. 1, 2, 3, 4 times. Multiplying my exponents first, I get 81 times my initial 4 inches, and I get 324 inches. That is how tall it is in the fourth week. What do you guys think? That wasn't so bad, right? Let's look at the next question. Mrs. Smith has 4 rows, and in each row she has 4 desks. So if you imagine that, 1, 2, 3, 4, with 1, 2, 3, 4 in each, can you see how I'm multiplying 4 by 4? Yeah. And each desk has 4 chairs. Okay, times 4 again. And each chair needs 4 tennis balls for the feet. I know you've seen that. When they have tile floors and they put tennis balls so that the legs of the chairs don't squeak on the floor. Write in exponential form how to solve how many tennis balls she needs. Well, I think it looks tacky, so I personally wouldn't put tennis balls unless I had to. But here we go. 4 written 4 times. And how much would that be? I know that is 16 and that is 16. So getting my calculator, or if you happen to know your perfect squares, 16 times 16 is 256. Wow. 256 tennis balls. All right. Next question. The local country club. Now, if for any reason these questions are in a different order, you can just turn around and get to the right page pretty quickly, right? Let's talk about the country club tennis tournament. Well, I must have had tennis balls on my mind when I wrote this question. But I bet you've participated in a tournament or you know someone who has. You're going to start with 128 players. During each round, half of the players are eliminated. Uh-oh. So to cut it in half, we'll multiply times 1/2. How many players remain after 5 rounds? Well, start with 128, then take half for the first round, then half again for the second, the third, the fourth, and the fifth. That's what the formula tells me. So I'm going to work my exponents first according to PEMDAS. 128 times, well, I know 1 times 1 times 1 times 1 times 1 is 1. What about 2 times 2 times 2 times 2 times 2? Well, I know this is 8 times 2 is 16 times another 2 is 32. Now, 128 times 1/32. I think I'm going to put my ghost 1 here under my whole number and say 128 times 1 and 1 times 32. Now I have an improper fraction. So 128, my division line, divided by 32. Box top it gives me the answer of 4. 4 players remain. Wow. After 5 rounds, you went from 128 down to 4. What's good old Grandpa doing here? He said he'd give me a penny. I wonder how many of you can write a penny correctly in decimal form. You know it's $0 in decimal. How do you write a penny? You can put 0.1? No, 0.01. That's right. And then I'm going to double it. So times 2. Every day for a week. Well, how many days in a week? That's right. 7. That is going to be a lot of 2's. So let's take a quick look. Times 1, 2, 3, 4, 5, 6, 7 2's. Again, we need to do, according to PEMDAS, our 2's first. I know that much is 8. Here's another group of 8, and then 1, 2. 8 times 8 is 64, and 64 times 2, if you need to, use your calculator, is 128. So 128 times my penny. I bet you know how much 128 pennies is. That's right. If you need to use your calculator, you have 128 times 0.01 is $1.28. Not bad, starting with a penny, and at the end of the week, that 1 penny turned into $1.28. Well, what do you think happens if we're going to go for 2 weeks? Start with that penny. How many days in 2 weeks? That's right, 14. I'm going to have to write small to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 2's on the page. I bet you have to erase and try that more than once. I'm going to circle my groups of 8s to make it a little bit more manageable. And this last group is 4. So I have 8 times 8 times 8 times 8 times 4. Well, I know 8 times 8 is 64. It's time to bring in the calculator. 64 times 64 times 4 is, wow, 16,384. I wonder how many of you know how many pennies that is, right? Every 100 pennies makes $1. That gives you a hint. But you can use your calculator, and I'm trying to get this to focus. Maybe if I move that calculator, it focuses better. There we go. You don't need to see the whole calculator. That number times 0.01 is correct. $163.84. All of that from 1 penny in 2 weeks. That's pretty great. All right, we are down to our last 2 problems, guys, and these are fun. This is something we're going to learn later in the year when we talk about volume. For now, I'm going to have you change where it says volume equals A cubed when A is the surface area. That's not right. When A is the side length, okay, of one side. So let's just write down here, one side cubed. So I'm going to show you how to draw a cube. Draw a square, and then kind of lay on top of it another square. Connect the sides. You want to get really fancy, you can erase all of those inside lines and touch it right back up. Okay? And so here's the length of one side. What is the volume of a cube with a side length of 4? Oh, well, we know that each side is 4. So the volume equals the side length of 4 cubed. Ugh, that's easy for us now. 4 times 4 times 4. I bet you've got it. 64. Great. And it didn't tell me if it was inches or centimeters or meters or even miles. So I'm just going to put a U for units and cube it, because we multiplied unit times unit times unit, so unit cubed. Let's look at this problem. This is the last one because it's a little more complicated. So again with the cube, and I drew it in the opposite direction this time, and it says, you know, one area of one whole side is 9 inches squared. And remember, we know that volume is the side length cubed. So if the square has an, oh my, I'm sorry. A square has an area of 9 units squared. That means what number times itself is 9? Or the square root of 9 is what? Did you figure it out? I hope so. It's 3. So, now we know that the side length must be 3 to have the area be 9. We can plug that 3 here and say our volume is 3 cubed. And if it's inches squared, then it's 3 inches cubed. And the 3, so that means 3 inches times 3 inches times 3 inches. You know 3 times 3 is 9. 9 times 3 is 27. And again, inches times inches times inches is inches cubed. So, nice job. You are now ready to put a little bit of glue on there and put it in your notebook. So, thank you for paying attention. I hope you got this done and learned a lot.